So here we go, FTTH part 2, FTTH components in detail. Equipment and their roles. OLT component, first component is OLT and its role is head and device, uh, central office. The two is fiber cable, the most important component. Patient reading. Number three, splitter. 1:8 backslash 1:16 and 1:32. And its role is divides signals to multiple horns. And number four, ONT. Number fourth component is ONT, converts light back to Ethernet inside the horn. Splitters are the magic wands here. A single light signal enters and it's split into many, like a teacher distributing notes to 32 students, for example. So, deployment methods. Overhead poles, electric poles, telephone poles, etc. Underground ducts or micro trenching. Number three, inside building. MDUs. In cities, for example, we often use micro trenching, cutting thin slices in the pavement to lay fiber. In rural areas, overhead deployments or aerial deployments on electric poles, mostly in Pakistan, is cheaper and faster. So, what's the biggest challenge in underground deployment? Obviously, there are so many factors, right of way issues, taking permissions from all the authorities or the utilities which are running under the road, for example, sui gas pipelines or other operating cables. So there are so many challenges involved while laying underground cables. Number five, testing, and quality assurance. Instruments used in this: number one, OTDR, optical time domain reflectometer, checking faults, splices, power meter, and light source for verifying signal VFL, visual fault located, for basic fiber continuity test. Testing is not optional, it's mandatory. A clean, well tested link is the foundation of customer satisfaction. So, a real life example, I will give real life example: FTTH for 1000 nodes. So, deployment plan: number one, one OLT port. If I kept it in this level, it will be much better. Example: FTTH for 1000 nodes. Deployment plan: one OLT port supports 128 ONTs. Okay. Splitter configuration: 1:4 in field plus 1:8 at cabinet is equal to 32 ohms per port. Estimated ROI 2.5 to 3 years. Internet plus IPTV plus VODP. ISPs calculate return on investment using these numbers. The trick is maximizing customer uptake while minimizing field maintenance. And now the future of FTTH. And FTTH will support smart homes, IoT, 5G backhaul. FTTH will support smart homes, IoT, 5G backhaul, integration with AI-based green FTTH using solar powered field cabinets, less power usage. Tomorrow's homes will have 50 plus connected devices from your fridge to your car charger. FTTH is the invisible pipe that will handle this tsunami of data or high flow of data. So the scenario for you. So it's an activity. You are tasked with designing an FTTH layout for a new 500 housing society. Designing an FTTH layout for a new 500 housing society. So the questions will be what architecture will you choose? Architecture you will choose. How many splitters and ports do you need? Okay. Where will you place your splitters to minimize cost? So key takeaways of both the lectures: FTTH uses fiber and light to deliver unmatched speed. PON is cost effective, scalable, and widely used. Critical components include OLT, splitter, ONT, and fiber. Deployment and deployment planning and testing are vital. FTTH is a building block for smart cities and digital economies. FTTH is not just a technology, it's a gateway to the future. Whether you are becoming a network engineer, planner, or technician, this is a must have skill in your toolbox. Practice the designs, understand the physics, and stay curious. Thank you very much.